So we talked about trigonometry on Tuesday and Wednesday of this week, and we were learning how we can use trigonometry, how we can use those three trig ratios that we learned about for sine, cosine, and tangent to help us really figure out how we can solve for missing angles. And we had a couple steps, we sort of had like a process that we were going through, but because that wasn't until we didn't learn that except for Wednesday, and it's been a couple days, we need to sort of refresh and review because yesterday's whole senior citizen luncheon. So one of the things that was important to use to help us solve for those missing sides was how can we, or we needed to figure out what were those sides. Did we have adjacent? Did we have a hypotenuse? Did we have an opposite? So it was just important for us to be able to label each side of those triangles just to know what information we were using so we could help us figure out, all right, which of those trig functions do we actually need to use. So if I have 40 degrees in my top left corner, we have those three options, adjacent, hypotenuse, and opposite. So we want to figure out which of those sides are which. So looking at this first triangle, I know that, sorry, this one's not on your paper, this one. Which side would you consider to be which? Just based off of what you remember from Wednesday. So opposite of the angle, so which is it going to be my left side, my top side, or my bottom? My bottom. So that's going to be my opposite. It's farthest away from our angle. It's on the opposite side of that triangle. Good. What other side do I have?
And the longest side.
Our longest side across from our 90 degrees, that's always our hypotenuse that we use. Good. And then that leaves our last side as adjacent. Awesome. So if we change our triangle a little bit, we put our 40 degrees in that bottom left corner. What are our thoughts? Which side is my hypotenuse? Crossing 90, our longest one. Good. What would my bottom side be? Adjacent, good. It's next to my angle. Our adjacent word means to stand next to. So it's the one next to our adjacent, or next to our angle that's not our hypotenuse. What did I leave our last one to be? So this is key to be able to label these, because if you label them wrong, then we're going to use the wrong trig ratio, which will give us the wrong number for our calculator, which then won't help us at all. And so we really need to be able to know how to label each of these sides in order to help us figure out, okay, which trig ratio do we actually use. Okay. So another thing that was beneficial for us was being able to solve those ratios, being able to figure out how do we actually solve for that missing variable in those proportions or in those ratios. So when we have just a single number equal to a fraction, what did we do in order to solve? Thinking back to we'll worry about SOHCAHTOA in just a moment. We won't use that quite yet. But if I were to try to solve for x, what can I do to help me?
You have to put 0.7 over 1.
So we can put whatever that single number is. We can always put it over 1. It's any number divided by 1. It's still itself. So we're not changing the problem at all. We're just drawing in an extra 1. Now that I put it over 1, what can I do now? Cattywampus, cross multiply, whatever you want to call it. So we can do x times 1 and 5 times 0.7. So x times 1, anything times 1 is itself, so we'll just leave this with x. 5 times 0.7, we can do that in our calculator, or that will give us 3.5. Okay. All right, compared to this first one to the second one, what do you notice is different about that second problem? Our 10 is our numerator, x is our denominator. Do you think we can still solve it the same way, though? Okay, so we can put our 0.5 over 1. We cross multiply that. 10 times 1 is still 10. X times 0.5, is this a 0.5x? What would we have to do from here?
Divide.
Good. So anytime we have that number of 20, divide it out. 10 divided by 0.5 could give us. Okay. Last question, what's different about that one? Cosine. How do we figure out what cosine of 20 is? Put in the calculator. Okay, so we have some calculators up here. I can grab these for you. So plug in cosine of 20, see what that number is. Once again, we can't solve these without our calculator. Because I don't know what the cosine of 20 is. I don't expect you guys to know what the cosine of 20 is. So we'll need these calculators for this. What did you find, Amanda? .939. So that equals x8. Once again, we like to go to those 3 decimal places just to make sure our answer is accurate, to make sure it's exact. On your state test, they will give you a range they put it in between. So the 3 decimal places will make sure your answer is exact enough that you'll fall within that range. Once again, we can put our answer 1, and then we can cross multiply. And we just have to put in our calculator what is 8 times our 0.939. What did we find? 7.51. Any questions over our solving for the x in these proportions? Okay, awesome. So that brings us back to actually using our trig ratios. So those were the steps we needed to help us set up our trig ratio. And now let's talk about actually how can we use these trig ratios to solve for those missing sides of our right triangle. So this should be actually on your. So thinking through our steps we did. Step number 1, we had to label those sides, just like what we were doing before in that warm-up. We had to figure out what's my adjacent, what's my hypotenuse, and what is my opposite. So looking at 25 x 14, what sides do we know which, or which sides do we know right?
14 is adjacent, x is opposite, and the other one.
We don't need the hypotenuse, so you don't have to label it. You can if you want, if it helps you, but you don't have to label it because we don't have any information for that side. We do know we will need to use the opposite. We do know we would need to use the adjacent. So thinking through our SOHCAHTOA, opposite and adjacent, what does that tell us? Which trig ratio should we use? So we know O and A. Look through SOHCAHTOA, we see O and A are next to our TOA, so that's going to be our tangent ratio. So we know tangent of 25.
0.46.
Okay, and we first want to figure out what is tangent 25 equal to. What is, so the question is, do I want to put my opposite in the numerator or do I want to put my adjacent in the numerator? So one way to always help remember this, because once again, it's one of those things we just have to remember. If we think through SOHCAHTOA, O comes before A. So opposite is going to be the numerator, adjacent is going to be the denominator. So that will leave us with x over 14. And now that we have the ratio set up, now we can pull out the calculator. Now we can plug in our tangent of 25. And let's see what that ends up with. What is our tangent of 25 from our calculator? 0.466. Okay. And so once again, that's still going to be equal to our x over 14. And then from here, we already know how to solve this. This is just like our warm-up. Put it over 1, cross multiply. So x times 1, once again, is just x. And we only just have to do 0.466 times that 14.
6.5 back to 8.
Yes. Any questions over this step you've covered? So once again, thinking back to the step we covered. Label our sides. Think through which sides do we have. SOHCAHTOA, what is that going to help us with? And which trig ratio should we use? Set up our trig ratio. Think through which number needs to be on top. Is it going to be my opposite side? Is it going to be my adjacent side? Cross multiply. Once you get these steps down, these will be super simple for you. You get these steps down, you'll be able to crank out these problems. And this will then help you with next week when we start solving for missing angles and when we solve for real life situations, how to find the height of a building using trig ratios. So once you get these steps down, once we practice through this and get it down, you guys will be golden. So walk me through this next one. What would you do first?
Find the sides.
Find the side. So what is 20 going to be?
Hypotenuse.
20 is my hypotenuse. It's across from my 90 degrees. It's my longest side of my triangle.
X is next to your square.
Good. So x is next to our angle, so that's our adjacent side. So we have hypotenuse and adjacent. So thinking through SOHCAHTOA, where do we see A and H? Top. So what is our trig function we're going to use? Cosine. So cosine of our angle, 42. When you're thinking, what is cosine of 42 going to be equal to? How are we going to set up our ratio in this situation? So if we think through SOHCAHTOA, A comes before H, so it's going to be adjacent over hypotenuse, so x over 20. And now we can figure out, okay, what is our cosine of 42? Put it over 1, just like our other situations. Cross multiply. Any questions once again over any of this? Alright, see if you can finish those other two on your own. See if you can take a moment. I'll be walking around and let me know if you have questions. Alright, so what do we find for our solution for that missing side? So x equals 9.969. Are we okay with this? Do we agree with this? Any questions of the steps we took? Cool. What do we find for x of our second missing side? 16.904. What trig ratios do we use in these problems? Sine. So from our SOHCAHTOA for sine. Yep. Good. Any questions about these two? So we have a couple more problems. They say on the thing, it says it's a little bit more difficult. I don't think you guys will find it more difficult. I think you guys will be able to breeze through these if you're really smart geometry students. We'll see what's different about them, but I don't think you'll find it difficult. So thinking through our steps once again, what should be the very first thing we do? Label their sides. So looking at 65x and 16 in our right angle. So it's adjacent. It's next to my angle, but it's not my longest side, but it's next to my angle. So I know it's adjacent. So it's far away. It's the farthest side. It's not touching my angle, so it's my opposite side. So if I have adjacent and opposite, thinking through my SOHCAHTOA. Our TOA, so that's going to stand for our tangent function. The tangent of our angle 65. Once again, we have to think.
I always do this.
It's okay. You're just ready. You're on top.
16 over x.
Good. It's going to be our opposite side, O, divided by our adjacent side. And now we can figure out what tangent of 65 is. So what do you notice is different about this problem compared to our last two, or our last four?
X is 16 is the numerator.
16 is in the numerator, x is in the denominator. So when you cross multiply, x will be multiplied by the tangent. And so we've seen these ratios before. We know how to solve these, so they're not really harder. It just adds one extra step to it, but it's nothing too difficult that I won't be able to handle. We'll be able to cross multiply. Our 16 times our 1, still 16. 2.144 times x. And And then once again, so the only thing really different about these problems is we're just going to have to remember to divide to get x by itself. So it adds an extra step in there, but it's an extra step that you guys already know how to do. It's something you've already been doing before, so nothing. And so 16 divided by 2.144, what did we come up with that?
7.416.
Any questions over this one or how it was different from the other? Simple enough. All right. I believe in you. I believe that you will be able to finish these other three. Once again, I'll be fine for our first one. What was that out?
7.463.
7.4. Sorry, I write the wrong number. 7.463. Do you agree with this?
This got it.
No.
That takes too much.
That was for that first one.
Oh.
The 65.
This one's
Oh, okay.
Remember, you
Yes.
put it wrong.
Thank you, Morgan. So what do we find for that second one?
17.68.
17.6. Yeah, that wasn't my fault. I'm sorry. Did we all agree with that second answer? What about our last two?
I didn't know.
616.
696.
And then our last answer.
4200.
What? I got 1.400.
1.4. So my guess is if you're off by your decimal place, it's just a word, and it probably means we probably hit the number wrong on the calculator, and we went 2 or 20. Because you have your numbers are in the right order, it's just your decimal place is off. So I assume. Oh, okay. So tangent of 55 is 1.42. Right, 14.
Okay.
So that's where our decimal. So one way to check to see if you got the wrong answer, or one way to think whether your answer is accurate, is if you're getting like 1.4 or if you're getting 4 for this side. On your triangle, if this side is 20, do you think this side is just going to be 4 or just going to be 1? It's a little short. Or if you get something that's like 80 for that side length, well, 80, this side looks like it's supposed to be smaller. So I don't think it's going to be 80. Now, we shouldn't always base our answer off of how the picture looks, because sometimes the picture isn't drawn to scale. And so our answer won't always be based on that picture. But if their triangle, or if your answer is really off of the other side of that triangle, that's something to check. Okay, maybe I should look back at my map. Maybe I should check one more time just to see if my work is correct.
What's the range that it should be within?
For like your decimal places,
Like, that would be okay.
So there's something called the triangle inequality, which we'll talk about, which compares different sides of your triangles. But really, if you're looking for like the hypotenuse, and your hypotenuse is shorter than one of your other sides, then that's something that should click. Or if it's far off by 5, or it really depends on how your triangle is shaped. So use your discretion. And once again, it won't tell you what the answer is. It'll just tell you, okay, maybe I should look back and check just to see if it works. All right, so I feel like we're pretty confident with our solving for our missing sides, which is great. That's something we'll definitely need next week. Now we're going to move on to a little bit more theories and talking about some things that we might notice that might come up that we'll have to think a little bit about, some critical thinking. So, on the back side, if you look at that first one, it says explain why tangent of 45, the opposite over adjacent, is always equal to 1. So if we plug in tangent of 45 on our calculator, we're always going to get 1 as our solution. Our goal is to figure out why. Why is that always going to be 1 every time? Doesn't matter what type of triangle it is, it's always going to be 1. If we look at this picture, what type of triangle do we have? Right triangle. What else?
45 degrees, so that's 45, so that's 45. Yes, 45, 45.
So one of our special right triangles, our 45, 45, 90 that we talked about last week. Now thinking through our mnemonic devices for 45, 45, 90, what do we know our sides are going to be for our 45, 45, 90?
Your two are gonna be the same.
Those are boo, 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 root 2. So two of those sides are the same, and that one was whatever that number was times radical 2. So if we think through this, tangent of 45. Now our tangent is always opposite over adjacent. My 45 degrees down there. What is my opposite side?
The one that's on the right.
This one.
No, yeah, no.
Alright, so on my left side of my triangle, my opposite side is far away from my angle. It's the side that's not touching it. Which one's my adjacent side?
The one that's next to it.
The one that's next to it. So if we were to create this ratio of tangent of 45, we know it's opposite over adjacent, so x over x. What's a number divided by itself?
Is that one?
So it's 1. So any number, it doesn't matter what number you have it for x, any number put in there is still going to be 1 as your solution. Anything divided by itself is going to be 1. And so tangent of 45 for any type of triangle will always be 1, because you know those two sides on your 45, 45, 90 triangles will always be the same. And so that's a cool trick. That's actually one of those ratios that you'll actually be able to memorize if you ever run into tangent of 45. Like, oh, I don't need my calculator for that. I can just put 1. Other than that, we'll use the calculator for the other one until you get to algebra 2 when you start actually memorizing these a little bit more. But you won't have to worry about that for now. For now, we'll. Alright, so let's look at another interesting thing. So if you take your calculator, plug in sine of 7, and see what that gives us. What was that? 0.121?
I don't know, what you?
I
Nine,
went
three,
9.9, yeah.
I didn't do.
What an interruption. Could the following students please come to the Welcome Center? Emily Heinroll, Grace Miller, Jada Miller, Connor Martineau, McKenna Parkmore, Abigail Norwood, and Casey Smith. Thank you.
We found sine of 7 to be 0.939. Let's check what the cosine of 20 is.
One more. I'm sorry. Taylor and Ada, please.
So the same thing? Why is that?
Because the main number is 14.
Alright, let's think. Sine of 70. What sides do we use for sine? Opposite, adjacent, hypotenuse, which one? The sine is opposite over hypotenuse. 70 equals over hypotenuse. Which side is my opposite from 70?
14.
Side is my hypotenuse.
The 14.
That would put me at 14 over 14.9. So that's my sine. And if we were to divide that out, that would be our ratio for our sine of 70, our 9.89. Now let's think about cosine of 20 from this angle. What sides do we use for cosine?
Adjacent.
Adjacent hypotenuse. Now from my 20 degrees, which side is adjacent?
The
My hypotenuse will stay the same, as always, same location. So that would adjacent over hypotenuse, which is once again 14 over 14.9. So sine and cosine have this unique relationship. Because they're sort of opposite, or because they use essentially the same sides from two different angles. So sine of 70 will always use that opposite and hypotenuse, but those will be the same if I use my other angle from cosine of 20. It's still that same side. the same two sides. So they'll always give me the same answer. So sine has this unique or sine and cosine have this unique relationship where the sine of an angle, say x degrees, will always be equal to cosine of 90 minus that angle. But why do we think it's 90 minus the angle? Say that one more time.
Something to do with the triangle.
Has something to do with the right triangle. So thinking about triangles, what do we know all their angles add up to equal? 180. But if one of those, with trigonometry, we always have to have that right angle in there. If one of those angles is already a right angle, how much do we have left for those two other angles? 90. So those two other angles will have to be complementary. They'll have to add up to equal 90 degrees. And so sine of one of your angles will always be equal to, they'll always use the same side as cosine of the other angle, and that other angle is always going to be 90 minus whatever your angle you use for sine. Because adding up plus that 90 that you already had to know with the right angle, it has to equal 180. So this is a unique little property that we can use sometimes. If you know what the cosine of a value is, when you're trying to figure out what the sine of that angle is on your triangle, you can use 90 minus that your value you have, and you know it will be the exact same thing for your sine. So if we use that, if we have sine of 50, we want to think, okay, what is going to be the ratio that's going to be equivalent or the same as a sine of 50? All right, so we know it's going to be 90 minus our value, or 90 minus our angle, so 90 minus 50 leaves us with 40. So we know it's going to be an angle of 40. But what ratio do we want to use? Sine, cosine, and tangent. Which one is going to be the same as sine of 50? Which of those two ratios had a relationship that we just talked about? Cosine. So it's sine and cosine. So it's always going to be one and its opposite. So cosine will always be sort of the opposite essence of sine. And so if you have sine, it'll be cosine. If you have cosine, sine, you're always going to have one of both, but they'll be equal to each other. And you can always figure out what the angle is by doing the 90 minus. It's really cool. If you plug in sine of 50 in your calculator, plug in sine of 40, once again, you get the same thing. And if you want a picture to help you illustrate this, that's a square, not a triangle. So if we have 50, the only possible value, once again, to have a missing angle, we do 180 minus 50 minus 90, leaves us with 40. Once again, our sine is always going to be that opposite of our hypotenuse, but cosine will always be our adjacent, which once again is the same side. So see if you can figure out, on this very last problem, what is going to be the ratio that's going to be the same as cosine of 35? What would be that trig ratio? 25.